I wanted to show you something that's quite the miracle and quite the coincidence. That is that there's some very similar patterns that are occurring on Earth with eclipses that occur on Triton 3 in the atomic galaxy of Trion. So what you're looking at here are Earth dates. These have been converted from Tritonian star dates, and these are also taken off of, they also show up on the Saros cycles, which is this stack right here, in the odds anyway. You can see the FMC numbers up on the top up in here. So, you can see this very well, but you can see the two boulder lines right there going horizontally in the purple. Between these two lines is one segment. That one segment is on our shadow wheel from the atomic galaxy of Trion. And there are the segments. The odd on the outer ring and the even on the inner ring. I'll show you another example of it. This one right here is with the odd and even merged together. The two rings merged together into one. There are 19 points on each segment right here. And these two are actually, they're actually, it's all one ring, the odds and the evens in one ring right here. And all these lines here and here are actually all together right here also, but quite obviously we can't put them in there because then there's no way to identify those lines the way we have them identified this way right here. So there's that. Here's another version of it too. Right here, this one right here is just the odds, and they're in a also one single ring, but it's split up into four to show the seasons on them. And actually, this copy of it, we have to reverse these two right here for a particular reason, so we do make some errors on some stuff and have to correct them. It's been a long road of doing that, but we're almost there. So yeah, there's a Trion Galactic Shadow Wheel 627A. It's also called the T4 FMC 19SW. That's the Tritonians, what they refer to this wheel as. So, okay, enough of that. So, the time duration of one segment is 1,803 years. each segment has these groups right here. There's 5 groups. 1, 2, 3, 4, and 5. You can see the 19 count down here of the eclipses that occur in that 1,803 year period. This here is the FMC's numbers that are in the group down this line. And these are the shadow types, the father, mother, child. That's what the Tritonians call these. That's in this line. These are the segment point numbers right here. 1, 0, 1, 0, 2, 0, 3. The segment point numbers are these right in here. Where is my pencil at? Anyway, you can see right here, this is SW09P01. This is the SW number, or shadow wheel segment number. This point number 01, point number 02, point number 03, point number 04, and on, all the way down to, sorry about the lighting and the shadows in here, 19. Okay, so back to where we're over here again. Here's the point, the segment point number. Comes down this line. And it's pretty obvious, but I'll say it anyway. This right here is a segment ending right here. This is beginning segment. And then ending here, and then beginning again. So it has group number 1 there. And group number 5. So over here, these are the number of years between each one of these eclipses right here. These numbers right here are almost exactly 19 years. It's off by, you know, I don't know, for less than an hour, 2 hours. There's 2 hours or less on each one of these, including the 315 years. The 315 is a group separator. Let's see right here. And in this case, it's a segment separator also, but you'll see that it's also a group separator. So this is the pattern number, the year pattern in which these fall on. So it's going to, the group separator is a 315 on these, on the odds. It's going to go 19 years, 19 years, 19 years, 296 years as a group separator. 19, 19, 19. Each one of these is a separator between each one of these eclipses and their occurrence. Another 315 separating the group. It's going to go 3 times. 296 is going to separate the group. 19, 19, and 19. 315 separating the group. And then ending on a 315 again. This will be the end of the segment, which will be exactly 1,803 years. Not even 1 minute or 1 second off from that. And what's interesting is also, that's the group, but also this one right here. Or let's say the 37 here. From 37 to the 37 year will also be exactly 1,803 years. So these are not exactly these numbers of years exactly. said they're off by maybe up to a couple of hours off from these years indicated here. But from one to the next, or from here to 37 down there, it's going to be exactly 1,803 years. From 35 back down to the other 35 in the next group or the next segment, it's going to be exactly 1,803 years. So, oh yeah, these over here, to show you what separates the from one segment to the next, are these, the shadow wheel numbers. These right here on this one, in this segment, these all land on shadow wheel number 11. And it lands on point number 17, shadow wheel 11. This is also on 11. These are the point counts in the segment. And then right after this one, when this segment ends, they're now going to be, it's now going to go to the next segment, or all these will be on 13. Again, the 19 points on segment 13. And after it finishes 13, it's now they're going to get repeat. Now it's going to start on 15, and all 19 will be again on 15 in that segment. So this first column right in here, as you can see, these are the solstice eclipses. These will take place in the northern hemisphere in the winter, and the southern hemisphere will be summer solstice. These are the shadow wheel numbers again. This is the month, December, day. This particular one doesn't exist on the Saros cycles. I'll explain a little more of that as we move forward. And obviously the year. So, moving up in time here. And I'm just going to go through this whole all the way down there. So in Triton 3, these eclipses, they exist. There's something I wrote down over here I wanted to read with some stuff on here, just so I don't leave some stuff out. So, all dates shown are Earth dates converted from Triton dates. They're shown here for comparison reasons. The colored lines where the day is missing is due to the fact that this eclipse date does not exist on the Saros cycle, and therefore does not exist on Earth according to NASA. So that's what these empty day spots are. They do not occur within the Saros cycles right here. And we will go through these, and I will show you that in just a little while. So let's see, also on Triton 3, all of these shadows have existed in the past or will exist in the future, meaning that all the ones shown on here existed before and will exist in the future. When you move past the current date, well, then these will occur in the future on Triton 3, including the ones that evidently don't exist here. Oh, these right here didn't get marked in color just because of a particular reason. We've got some pattern that showed up on here that I'll show you in a minute also. So, for Tritonian star dates and times for these right here, from what they were converted from to these, and then, you know, for comparison reasons here, the ones that are not on here for Tritonian dates, they will be on the shadow wheel, Triangulactic shadow wheel 627A. they will all be there later. We haven't gotten there yet, but these are only the ones that are shown right here. These dates, these are all on the 27F. That's what this center marker line is the 27F, and I'll show you to tell you more about that incredibleness a little bit later too. But all of these right here will eventually, in time when we get to it, will all have the Tritinian dates on them along on this entire wheel. So currently they're not there, but they will be there later, and that's why I wrote, or that's why I said that for Tritinian star date times, see the Trion Galactic Shadow Wheel 627A right there. Again, because they will be there later, just not there now. Okay. So, all right, moving on over here. Going to go over to Northern Hemisphere fall, Southern Hemisphere spring, equinox. These are the dates that these will fall on right here. Again, these are Tritinian dates converted to Earth star dates. And the ones shown on here, the ones that have the days on them, they exist on the Saros cycle. The ones that do not have a day there or marked in the just the line right there are non-existent on the Saros cycles. Okay, what do we got here? Northern Hemisphere summer, Southern Hemisphere winter, solstice. And Northern Hemisphere spring, Southern Hemisphere fall, equinox. Okay, so something to notice here is that the current time in which we live here on Earth, is well right inside of here. There's 1862, 2177. And there's a gap in there is because there's the 315 year group separator right in there. Here's 1960 to 2256. And there's 1982, 2001, 2020, 2039, all within our time here, approximately. And $1765, 2080. So these that are boxed in the green, as you can see, most of them have an eclipse on the Saros cycle that appears. There's two that do not, and all of those do. And this one that does not, another one that does not, the rest of them, there's another one. So I'd say that's quite the miracle that the shadows that occur on Triton 3 and the pattern that exists over and over, a cycle that exists over and over just in repeat, largely exist in these green boxed in areas right here. But going back in time, largely do not. Well, you can't see that far back, but you can see in the future. And I can guarantee you that you can even look on this, the sorrow cycle itself, and see that moving back on this one right here, moving back, it will be the same as what you see over here on this one over here. Non-existent, largely. You move back far enough, not too far back, like from right here, from this point on right here, moving back, it's non-existent completely. It will not come back again. Then right here, there's just a little bit, but from here on, it's completely evaporated. None of these will show up on these solstices. Same thing from right here, from the 0863 back, never to be seen again. From here, from the date of 3158, or from 2862 is the last one. After that, there will be none. Here, last one, 2764, never to be seen again. Here, last one is miraculously, also, I was surprised this one showed up on here on 3038. That's the last one. After that, they're gone. And over here, it doesn't show. Also, same thing. If you go look further into here, it will just do the same thing. They will not exist. So, quite the miracle. Quite the coincidence, wouldn't you say? Also, the reason why I marked these in these colors the way that I have them on here, which I didn't even know that was going to be there until I started putting these date conversions and organizing it this way on here. I saw that there's this pattern in which you have two that are non-existent and two that do exist, and then the rest do not. If you look over here, you'll find that, and this is going backwards in time on this solstice, and then going forward in time on this equinox, it has the same pattern. How that is, I could not tell you why that is. But again, two that do not, two that do, and then the rest do not. Two that do, two that do not, two that do, the rest do not. You can see the same thing happening inside of these boxed-in areas. It has two, and then two not, the rest do. You go back over here and go in reverse. From that, two that do not, the rest that do. Over in these boxes, same thing. Three do, one does not. In reverse, three do, one that does not. Four that do, four yes, one no. Three yes, and four yes, one no. Three yes. Same patterns. Same thing if you look, well, you can't see too much of it, but you can see right here where it has 2 that do not and 1 that does. This shows more moving down here, so you can't really see the pattern in full right here, but you can see the 2 that do not, 1 does. I'll show you back here, 2 that do not, 1 does. So I'm going to have to stop the video and make another video on the Saros cycles on here. Oh yeah, that's the even numbers. This is the odd stack. I was thinking not to make this part of this video, but then I thought, well, showing you all this, people will just think I'm some kind of crackpot. Have a whole bunch of crazy shit on here that, sorry the language, but that's the way I talk all that. Think I have a lot of crazy stuff on here that has no relation or it's completely false. So, okay, so I'm going to run through all these Saros cycles and check the dates on here on this entire page, this entire sheet, just to verify and show you that all these locations of these eclipses are in fact on here. The ones that have an actual day on them, as we talked about earlier. So what we're looking at here is the FMC 17 right here, 17C. I'm going to go across this whole line right here. Starting on this solstice right here, and we're going to move across. So we're looking at year 727 in December, which doesn't exist because the Saros cycle doesn't begin until 9:44 on April 25th. That's why it's marked with the yellow line there. Doesn't exist. Moving on to 1178, September 13th at SW 63. And just have to look for the 63 on here. We can find it. 1773. Sorry about that. Went an entire cycle ahead by 594.99 years. So we're right here, 1178, September 13th at 63. Next one is 1629 at 47. 1629 at 47. Next one we have here is 2080 at 31. 2080 at 31. Okay, moving down one line here to 19. And 19 is Saros cycle 131. We are starting at December of 746 and non-existent starts at 1125 on this Saros cycle. Moving to 1197 at 63. 1197. If the phone will refocus. No way it's doing that. Why are you doing that? Alright, whatever. So 1648 at 47. 1648 at 47. 2099 at 31. 2099. 2099 at 31. Okay, moving down to 21. Okay. Starting at December. 765. 13 on the 13th. 765 doesn't exist. Oh, we're at 21, and this is Sorrow Cycle 141. And 765 doesn't exist. It doesn't begin until this Sorrow Cycle begins at 1613. So again, obviously 1216 also does not exist. And 1667 at 47. 1667. 1667, 47. And the next one here is 2118 at 31. 2118 at 31. Okay. Moving to 23. It's 23. Solar Cycle 151. First date shows up at 0784. And this does not begin until 1776. So we have 3 of them on this one that don't exist on there. 1686. First one starts at 2137. Twenty-one 37 31. I'll show you on here that there's more that'll land on here on the 2137. Go up 450.75 years, or 1/4 of the 1803. Just going to put that at 2588 or so. Let's check and see. 2587. December 20th. See, so it lands, you move up 1/4 of the 1803 from here, and you're going to go to the December solstice from the equinox, the March equinox. Again, that's 450.75 years. That's what all these are, of course. They're 450.75 years apart from each other across the line. So all right, moving along. 01. Okay, 01 begins at 1080. This cycle begins all the way back in 792, so 1080. Where's 1080? Oh, there it is. 1080, December 14th on 13. Okay, moving on to 1531 at 63. 1531 at 63. Next up is 1982 at 47. 1982 at 47. Next is 2433. Cycle ends at 2054. Okay, moving on to 03. 03. Saros cycle 127. 1099 at 13. 1099 at 13. 1550 at 63. 1550 at 63. 2001 at 47. 2001 at 47. 2452. Not there. Cycle ends at 2416. Moving on to 05. Okay, 05. So cycle 137. 1119. Begins at 1389. Next one up is 1569 at 63. There it is. 1569 at 63. And 2020 at 47. 2020 at 47. 2471 at 31. 2471 at 31. And next up is 07. 07. Saros cycle 147. This one begins at 1138. And doesn't exist on here. It says it starts at 1624, and 1588 also is not there. 1624. 2039 at 47. 2039 at 47. Next up is 2490 at 31. At 31, 2490 at 31. Alright, so we're going to $25 is 123 at 1452 and 13, 1452 and 13. Next one up is 1903 at 63. 1903 at 63. There it is. 1903, 63. And 2354 doesn't exist. Ends at 2318. Okay, moving to the next one at 27. We are at 27 and 133. First up is 1471. 1471 and 13. Yeah. 1471 and 13. Next up is 1922 and 63. 1922 and 63. Next up is 2373 and 47. 2373 and 47. Next is 2824 at 31 and doesn't exist. Ends at 2499. Okay, next I'm going to go to 29. 29. 29 and 143. First up is 1490, doesn't exist. Cycle begins at 1617. Next is 1941 and 63. 1941 and 63. Next is 2392 at 47. 2392 at 47 there. Next is 2843 31. 2843 at 31. And moving to 31, 31, 31, and 153, starting up at 1509, doesn't exist. Cycle begins at 1870. Moving to 1960 at 63. And 1960 at 63. Okay, next up, 2411 at 47. 2411 at 47. Next we have 2862 at 31. 2862 at 31. Okay. And moving to 09. 09. 09 and 119. First up is 1805 at 13. $18.05 at 13. Next we have 2256 at 63, and doesn't exist because it ends at 2094, and those are not there also. Alright, so we're 11 now. We're 11 and 129. We have 1824 at 13. And 2275 at 63. 2275 at 63. 2726 doesn't exist. Got 2528 there. And of course that doesn't exist down there either. Okay, moving along to 13. We have 13 and 139 and 1843 at 13. 1843 at 13 there. Okay. Next one up is 2294 at 63. 2294 at 63. And 2745 at 47. 2745 at 47. And next one is 3196 and doesn't exist. The cycle ends at 2763. Okay, next one we're going to 15 and 149 at 1862. 1862 and 13. 2313 at 63. 2313 at 63. 2764 at 47. 2764 at 47. And 3215, not there. Cycle ends at 2926. Okay, next one at the 33 and 125, beginning at 2177 and 13. 2177 and 13. That will be right there. Okay. Moving to 2628. Doesn't exist. Ends at 2358. And of course those don't exist either there. Okay, moving down to 35. And 35. 135. First up is 2196. at 13. Next up, 2647. Not there. Cycle ends at 2593. Okay, last one for this is going to be 37, and 145. You have 2215 and 13, 2215 and 13, 2215 and 13. And 2666, that's 63. 2666 at 63. And 023117, not there. Cycle ends at 3009. So that's the end of that. Alright, so that's the end of the video. Thanks for watching. Okay, so I put in the Tritinian shadow dates for this paper here. Previous video I had just the Earth date conversions on there, and so anyway, the Earth date conversions, I don't think I mentioned that before, that they're not exact matches. So there's the Tritinian dates, and they're most of them are fairly close matches. Some of them are not. Point out some of this what I'm talking about in here. Like right here on these, December 14th and December 14th. These seem to not fall quite into place. And there's these at the 13, September 13, September 13, and the June 13 here. There are these over here that are September 10, and a December 11 and December 11th. Now these right here just have to do with what I call the 1582 problem, which we will show you some information on that. So this is normal here, but these over here are questionable as far as any lineups with what the Tritinian dates are. So I just wanted to point that out. Also, show you the real significance of what these segments show, these 1,803-year segments right here. From the purple line to purple line, as I talked about before. These right here on these solstices, the north winter, which is the northern winter, and the southern summer solstice on there. So the solstices for Triton and Triton 3 and Triton 4, they will all align on the Trine galactic plane right here, north summer. South winter will align here, and north winter over here on this side, this being the galactic plane. And then of course there's the north spring and the north fall. So I wanted to show you that. It's pretty incredible. That's why this that's what these all do right here in this order. So I guess I'll run through the Tritinian dates here. As I said before, the Tritinian dates, all these are shadow dates. Every one of them shows up on Earth. They don't show up on these places where they have the marked colors here, at least on the Saros cycles. Down here, these two right here are these two that I couldn't really write the date in there because of this purple line running through here. This would have the Tritinian date written in here, and that right there, as you can see, this 0412 right here, 0412, and the 2215 right here is not on the line. It's the same thing with all four of these columns here. Okay, so I don't know if I showed these last time or not. These are both the winter, or the even, and the odd. This right here is all the odd FMC 38. This whole sheet right here is all just in the odd. Right here, as you can see, the 33, 35, 37. Okay, and here are the sheets for both of these. That's the odd over here, and this is the way that the even runs right here. It has a different way that it's aligned. At the beginning of the segment, it starts at a 296, where these start at the 315. It runs a 296, 315, 296, 315, 315, and then back to 296. They both equal exactly 1,803 years. And here's all the point numbers on the segment running down here, and the FMCs, and the missing ones on this particular date alignment on here. So I don't know whether there's something else. I think that's it. Okay, so I did miss something. I felt like I was missing something, but I'll show you what I was talking about with this right here in the galactic plane and the North Summer, North Winter, North Fall, and North Spring on there. Well, there's this guy. Give you a little look here. So anyway, I'm going to go over this paper a little bit later, but I just want to show you the, there's the North Summer line, North Spring, the North Winter, and the North Fall. So, alright, that's it. Alright, so I wanted to mention something before I get started on explaining this complex shadow wheel here. First one is, we're not quite finished with presenting all of this. There's still more work to do, but we've run out of time, so it's going to be presented at the point at which we're at, which is not complete, with some drawings that we still want to make. Some of those drawings are would be drawings to be able to explain this a little bit easier. but those will come later, but they're just not here right now. So anybody watching this before we're finished with the other ones, and hopefully you get an understanding of what I'm going to show you. So there's a lot happening on here, and so it's really quite complex. So I thought the best place to start is actually, you might say, at the end, which is actually the beginning of where the creator created it from. And then as it gets divided down further and further and further, it becomes more complex, as you would see in some of these other drawings on here. Right here. So we're going to start over here. And this is the 627B. That one, of course, is the 627A, and there is a 627C also. And everything from the B on to, which I haven't even completed them, the others. There's going to be C, D, E, F, G, I think H. I don't know how many there's going to be, but there might be up to like 10 of these to be able to break this down and show you what's going on here. So I wanted to point something out first because, you know, we just printed these yesterday. I have to drive into town 30 minutes and pay $25 for each one of these, which we do not have money. It's like we don't have any money to be spending $25 on each one of these copies. Probably this one here didn't have to be this big. Not even probably, it didn't have to be this big. Just kind of just following this one right here. These do have to be this big in order to be able to show the numbers down inside of here. Otherwise it just gets too small. So, quite obviously there was a mix-up or misunderstanding on this right here. This was an R, I think, and then it got changed to a Y, which was something that just, like, there's a story behind that, but I'm not going to go into that. So it is what it is for now, from what we have. And so you can see where this right here has the cycle R right there. So anyway, we look right here. Cycle K is 18.03 years times 33. Okay, that equals the 594.99 year cycle, or cycle R. That's going to be times 100. I'm not even going to read through these because you can just look and see yourself right here. So that's the number of cycles. And this is the number of years in the quarter cycles of these. Quarter cycle number is really quite important because they're seasonal cycles. Very big seasonal cycles. Like right here, winter is 534 million years plus some change. That is from right here or from there. And it's the beginning of winter, and then it ends over here at 1,069,107,781.5 years, and it began at this one right here at the 534 million. So these cycles right here are, these quarter cycles are these, from here to there is a quarter cycle, from there to there a quarter cycle. So it goes all the way back around, one full cycle. One full cycle on cycle N is 2,138,000,000 year cycle. So I could go over all these on there, but it's pretty much self-explanatory. That's the way I wanted to try and make a lot of these different 627B, C, D, and on through, because each one of them will show something entirely different from the other one. So we'll just go through some of these quarter cycle dates on here. There's the 1803, and I don't think I can really do this because they're all upside down. 45075. It's the 59499 cycle, cycle R. This is also a sun cycle. That's some incredible stuff. I already have a sheet on that, but I haven't printed it yet. Of course, my son makes all these. I design them, and he puts them in digital form and puts them on a PDF for me, and then I print them in town. So anyway, here's this line. Let's just start here. So this is the end of the cycle, also the beginning. So just think of this as essentially all zeros right here. And then it's going to go to this quarter cycle here. Next quarter. And the next quarter. So it finishes here. Then resets and goes back to 0. Alright, I think I'm done here. Alright, moving on to the next drawing here. The 627C. And I point out some of these planetary alignments. All of them, actually. Start with the 0, 1 here. Let's start with an explanation of what these rings right here are. These four rings are actually one single ring, but they have different eclipse or shadow times on here. And this is 1/4 of the cycle of this full cycle of 59499. This is 1/4 of that. This is half. This is 3/4, and then back to 0 or back to the end of the cycle. So again, it's one ring split up into 4 seasons in 4 quarters. So let's see. North summer, north fall, north winter, and north spring. So right here, Triton and all 11 planets of the Triton system will align to the atomic galaxy of the Trigalactic Plane on that right there at the end of the cycle, or let's say the beginning of it, 59499. And then 14,874.75 years later, these are exact numbers too, they're not approximations. That will happen exactly 14,874.75 years after this alignment. This will happen. So, and this one right here says all planets will align. That's this right here. This is the, we're looking at here, we're looking at the, yeah, the North Spring. Okay, so it's going to be up, pointing up, and this one's down from the galactic plane. So then again, 14,874 years after the North Spring, or Cycle Y Summer. That'll explain a little bit later too, because there's a, I'll explain why there's that difference in there. It took me a little while to understand that one, because anyway, finally got it. So 14,874.75 years after this planetary alignment, they will then align here, which is going to be the North Winter alignment here on the galactic plane. And then it will go back to the North Fall, and it will be right there. Then back, finishing again at North Summer, and back onto the galactic plane straight across from the winter. So that's on the 0-1. And yeah, the next alignment is right here. It's doing exactly the same thing right here. And here on the 45. So you start back at the 1. So these take place about, there's 12 of these, and those 12 will happen I remember it's like just a little less than 5,000 years of the 59,499 year cycle divided into 12. So this one right here will happen basically at, let's just say, year 0 right here, okay? Starting at 0. Then, yeah, right here is the next one. The next planetary alignment will happen right here at this the North Fall Cycle Y Winter, 4,958.25 years later. Exactly. And there's the next one. The North Winter Cycle Y Spring will happen at 9916.5. And then this one, 14,874.75. And it just goes around and around until it completes all 12 alignments, which will happen, all 12 of them will complete again at the end of the cycle, and then restart again and do exactly what it just did. So The North Summer cycle Y fall is a 0 point right here. This is where the cycle ends and then begins right here. So the next one is over here. This one over here. There. And something you'll notice right here quite obviously is the creator loves to work with 3. I'll mention that throughout the videos because you'll see that happening very frequently everywhere. Some of it moves in 3, 6s, and 9s, or some cycles, some particular cycles they'll end in a 9. But 3 is the creator's special number. 1, 2, 3. Just as there is right here. 3. 1, 2, and 3. And then you might think, well, each one of these has 4. Yes. If it had 3 in each one, it would be 9. But the 3 times 4 makes 12. This comes back to 3 again. Again, like I just said, the creator loves working with 3. Alright, that's it. Done here. Alright, there's additional, something else I wanted to show you on this drawing that I don't think I mentioned is that, it's pretty obvious, but these are all 19, the 19 odds on this ring. And they're the primary ones that we work with because they have all the planetary alignments, they have all the magnetic excursions, magnetic flips. They're the ones that land right on these quarters, marking these points on the cycle. So most of our drawings are going to be with the 19 odd. Each one of these segments right here has the 19 points on it, which is the same as on this drawing right here, as we went over before. We have 1,803 years from segment to segment. There's 33 segments all the way around in total on the odd and 33 segments on the even. And the 19 times the 33 equals the 627. That's why this paper is called the 627, because it has 627 points. And remembering that there's actually this one ring here, so that's 627 points. So to understand these differences between, like in this case, the North Summer and the cycle Y fall, the 59499 is the cycle Y. So this is the fall line for this entire cycle right here of the 59,499 years. That's why there's a difference here, because this is a 1 year seasonal indicator right here, and this one here is the 59,499 season, and that's the same way with all these right here. That's why there's this difference between these two on each one of these lines. Okay. So here is the 1254A. And this one has both odd and even on it, so you can see that one. There's the odd, just as it is on the other paper. And there's the even. So here is the odd in alignment. That's the one ring of the odd, broken into 4 seasons. This one right here is the even, which is the 66 is the last one in the ring. That's the beginning and the end of the cycle on the even side. As you can see, there's a slight offset between the two here. There's the one center of the segment and the 66 center of the segment. That difference right there is 176.5 years in an offset on there. And in degrees, that works out to be 360 divided by 59,499, 360 degrees, times the 176.5 years equals 1.0679171079 degrees of an offset. Alright, so this is going to be just a little bit more complex than some of the other videos. I'm going to get a little bit deeper into this. So we are still on the 627A over here. These are all odds. And we'll move over to here, back to the 0 point line. This 0 point occurred on an Earth date of 2020. It was a June summer solstice eclipse or shadow on this 0 point line, 41,116 years ago from 2020. So looking deeper and going back much further into time, these right here are the pencil lines I just drew on here, right there, and that one right there. They are directly in line right here to the 01, which goes all the way back to the North Summer or Cycle Y Fall. And from that 0 point line right there, begin summer was 2,216,337.75 years ago, and beginning fall will be 13,982,265.00 from the 0 point line. So each one of these right here, as you can see, these are 1/4 of cycle O. Cycle O is the one-quarter cycle O is 16,198,602.75 years, and a full cycle O is 64,794,411 years. So here's 1/4 of cycle O, 1/4 of cycle O. From this red line to this red line is one full cycle of cycle O. And over here, from the 0 point line, this was 252,000. Our first day of summer was 252,870.75 years. Fall will be in 237,996 years from 0 point. So also from 0 point right here, you'll notice right here, some might find this interesting because this was beginning of the winter on this cycle, on this one. and then beginning of spring was 743,737.5 years ago, plus 41,116 years. As I said before, 0 point was 41,116 years ago from 2020. So 743,737.50 plus 411,116 years was beginning spring, or the end of that ice age that occurred at that time. Same thing over here. Right here was 34 million years, 613,543.25 years ago was the first day of winter. And these are each one of these quarter cycles right here. But if you go back and look on this 2 billion year cycle, first day of spring was 666,359,50.50 plus 41,116 years. That was the beginning of spring after this more than 500 million year ice age that began in this 1,200,000,000 years ago, and again ended here, and then went all the way through spring and began summer, 131 million years, 805,000, and puts us to right here where Triton 3 is at. If you notice this right here, you can see this begin summer right here at this negative, or 2,216,000 years. There it is right there on this cycle. And same thing here, the negative 252,000 is, where is it? There it is. 252,870. 252,870. You can also find the same thing right here on this 13,982,000 begin fall right here will be found. Let's remember this number is 13,982. 13,982. There it is right there. Like clockwork. And 237,996. That can be found up here, 237,996. 237,996. So in this one right here, they have this is slightly different from one of the other papers. It had this changed to just zeros right here because of the 0 point moving up 1 quarter cycle there and 1 quarter cycle here. So at 0 point here, you can see it moving up the 1 quarter of the 1 quarter cycle of the 59499, and then moving back right here The reason why this one right here and this one right here and is in alignment with this is because this is the same cycle. This right here is the fall of right here, so it's a 0 point on this same line right here. So you have fall, fall, and then winter, spring, and summer. And then the same thing going backwards there. This right here is a little bit different because this right here is a sun cycle, and it's working in the 59499. There's 100 of these compared to the 33 that's on these other cycles. And so anyway, it has a red line because at this time it was a sun cycle high. So these are running in highs and lows. There's a high, low on the sun cycles. And there are 100 of them from 0 point here to right here, 59499. There's another 59499. So there's 200 of these segments in here because the full 59499 cycle has been split in half into the blues right here. So there's 200 of these, but there are really actually only 100 of the 59499.99 cycles on this ring right here. So yeah. So let's see. Yeah, okay, that's it for now. Okay, next up we have the cycle Y. Point out there's winter, first day of winter, first day of spring, first day of summer. So I've created these over here. You can see that one right there. 41,116 years to June 21 of 2020. So that's in the negative. Going into the positive is going to be 29,749 years. Right here, 0.5 years. That's going to be the first day of spring. That comes to 11,367 years ago from Earth date of 2020. June 21 was the first day of spring on cycle Y. Cycle Y equals 59,499 years. And here's the breakdown on all this. I'll just drew a big old line through all that. It's wonderful. So the end of this more than 500 million year ice age, first day of spring was 666,359,050 plus the 41,116. End of that winter cycle was 666,400,165.5 years ago from Earth date of 2020, June 21 was the first day of spring on cycle N. Okay, so next one is the end of this 64 million year cycle at this date here, which is there minus the, or plus the minus of the 41,116 years, comes to 18,446,056.5 years ago from Earth date of June 2020. Was first day of spring on cycle O. Okay. So next one right here on cycle O, now on cycle T, 743,737.5 minus an additional 41,116 years comes to negative, or 784,853.5 years ago from Earth date of June 2020. June 21, 2020 was the first day of spring on cycle T. And, oh, this one I got started right here, but I had to move it down to this page. So, okay, there's that one, we went over that one. This one right here is, again, the sun cycle, but it's the cycle R. That's this one right here. So, to point something out that's quite interesting, because the 594.99 times 69 of those cycles goes back. 594.99 times 69 equals 41,054.31 years. And when you subtract that from the 41,116 from the 2020 date of June 21, you come up with 61.69 years. So that's 61.69 years ago. So 2020.47, which comes out to the June 21, equals the 2020.47 years minus the 61.69 years right here comes to 1958.78, or October 12th, which is the sun cycle high. You check that because it actually correlates with Earth quite well. These are all Tritonian cycles, but they correlate pretty well with Earth cycles, especially in this current time. So check that out for yourself and find that out. So 2020.47 is FMC 27F, and so is 1958, October 12th, FMC 27F is a sun cycle high. Now this is not sun cycles, the 11-year cycles I'm talking about here. This is a 297. I have that over here, right? Yeah. 297.495 years. The half cycle right here. So, or again, the full cycle of 594.99 years is the sun cycle I'm speaking of, which, as I know, nobody knows of that sun cycle. So, surprise, surprise, you're about to find something out. I have a whole paper on this. A lot more information on that, too. So, Triton, the sun Triton, star Triton, is the controller, like a brain, of this entire system. It controls and moves around all of the spheres within the Triton system, right on, in absolute precision. And this is just my opinion, but I think if any of these spheres, any of the planets, anything gets off track a little bit, it can actually get it back on track by increasing its magnetic output and then getting it back on track. Just like a brain, it knows what it's doing. The sun, Triton. Okay, I think that's it for now. Okay, next up, just wanted to point something out. It's pretty obvious, but probably not until you look at it for a while. But so every one of these right here, from this point to this point, or at least on the sun cycle ones, on these 59499s, it's not cold from here to here and then hot from here to here. It actually has these other midpoint cycles in here, just like the other ones do, like a midpoint in the cycle that's not hot or cold. It's like a warm cycle, just like a fall or spring. I forgot to mention that on the, well, you see it on the other paper that I have for the sun. As a, you'll see in 1810, check it yourself. In 1810, which is 1/4 of the 59499, in 1810 you will see the the cycle low on this at the 69. This 594.99 times 69. Anyway, you'll see a cycle low in there on 1810, which is also falls right on the 1/4 cycle of the 594.99. So anyway, moving on. Right into here, which was the end of the last ice age for this cycle. Well, from there it's going to go to summer, then fall, then winter, and back to spring again. So this cycle is constantly repeating, meaning that this ice age or this cold period in here, or until this spring right here, will again happen right here, and again here, here, the new spring, and of course this one right here is going to do the same thing. This was the spring for this time. It's the end of that late ice age period right there. It lasts for 500,000 years, I think, on that one. And yeah, you can see right here, 500,000 years ice age. So anyway, there's one cold period there. Here, going backwards. Here. So all these cold periods, ice age periods, are all within the other cycle. So these happen, you look all the way back to here, these happen within this cycle. Then these happen within this cycle. These happen within this cycle. So when this one right here is in a more than 500 million year ice age, well, this one right here goes into warm periods and cold periods 33 times during this entire cycle right here. So this will have ice ages on top of this ice age, and then this one will have ice ages on top of this ice age. This one will have ice ages on top of that one, and this one. So I hope you understand that correctly right there, because it's not, this one is not creating this one and then this one and this one. These are happening over and over, repeating within this cycle right here. And then these are happening over and over and over and repeating within this cycle. And these are happening right here. So again, all these are within this cycle right here. All these are within this cycle. All these are within this cycle. So there's a point in here. I haven't actually rotated these in a way that you can see that, but that's one I should make, where you can see all of these right here, all the winters. Rotate all these right onto this line right here, because there's a point where all right in the center of each one of these will align to right here, and I'll bet it's pretty cold to have this in the middle of winter, this cycle in the middle of its winter, this cycle in the middle of its winter, that cycle in the middle of its winter. Okay, now you're in some deep cold. But it does the same thing over on the warm side. It'll get very, very warm when all the warm cycles all align to right here, cycle in summer. Very hot, very cold when they all align there. Okay, I think I'm done there. Okay, so this part of the video is going to be on the T3 geomagnetic excursions and T3 magnetic field strength. So these excursions occur approximately, these dates do not happen at an exact time, and they don't last for an exact time, so but they will average over into this exact time of 3,718.6875 years. So there's 16 of them that happen over 59,499 years. So going back to this point right here at the 0 point, or 41,116 years ago, was a magnetic excursion. Each one of these right here, number 2, has 3,718.6875 years subtracted from the 41116. So here they are moving down here. So these fall on these move on the 594.99 year sun cycles. You see right here where I drew in a pencil mark right here at the 0 point, or this was 41,116 years ago. That one there. The next one, number 2, 37,397 years, would be right here, which is directly between the sun cycle high and the sun cycle low at this point. The next one is at 33,678. That one will occur here on the low of the sun cycle. Next one, number 4, is going to occur in between the low and the high, and then back on the high, and at the 1/4 mark of the cycle Y, or 14,000. The 14,874.75 years, 1/4 of cycle Y. So they're going to move around, doing the same, dropping off at the same locations around through here, and here's where things are going to get quite interesting. Because there's quite a similarity in the Earth cycles to the T3 cycles. So moving down here, you can see this one, number 12, ends up at 210.4375 years ago. All these down to the 12 are all years ago, from 2020, June 21. So 2020.47, which is June 21st, minus the 210.4375 here, comes out to 1810.0325. So here's the 1958 October 12th sun cycle high that I was speaking about before. Here is the low. It looks like I penciled that in there wrong. That's supposed to be 1661, I think. 1661.28. So the center point on that is the 1810.03. You can find all three of these. The 1858 October 12 high, it's very close to that. The peak that they have marked at is like 1958 March or something, April. So it's not a direct hit on there. And the 1810 is right dead center on a low in there. You'll have to see what I mean by the low on there. It's like a middle point, because the next low, or the 1661, is was the mini ice age that happened recently. So anyway, that's what that is. I'll go through all these dates. I point out something on here. These that have these marks right here, these lines that I marked on here, are significant marker dates for the for these magnetic excursions. If you check out, you'll see that Earth has correlates with some very significant magnetic excursions, especially this one, which actually on Earth was turned into be a magnetic flip that stayed flipped for about 500 years before it flipped back again. But it was essentially a magnetic excursion, not a flip. And this one here, the 33,000 year magnetic excursion, was also a significant one on Earth. And the 18,000 year one, that's one I can't remember. I've actually tried finding information on it again. I found some on it, and can't find it again, but there is some information on this event here. These others right here seem to be pretty much unknown on Earth, but they are magnetic excursion events and times that do occur on Triton 3 to varying degrees of how far they move off of their pole location. So anyway, thought I'd show you that. That's this. Here's this 210 2020. Yeah, already went over that. This one right here now turns into the future because from here is all in the past or ago, and these are all now in the future from 2020. 18383 plus the 41116 equals the 59,499 years. All right, I think that's it. Okay, so I'd like to show you an absolute miracle that has occurred here on Earth, and that is these eclipses that appear on the Tryon Galactic Shadow Wheel. Those on the 63 line. These here on the 47 line. Trying not to turn this upside down and go around. That one on the 29. And the 13. Just as they are over there. So we'll start on the outer ring, which is North Summer. We'll take a look over here. This is our current time. You see the 2020 right there is, I use that as a marker here because it's essentially in the time we live right now, and it's on this shadow wheel. That's the 41,116 year marker from the beginning of the cycle. So anyway, we have these eclipses that occur right here that are right in line with the same dates that Triton 3 has shadows occur. So it's quite a miracle that this can occur on the shadow wheel for one, and then also that they're here, but they were not there in the past. 1276 moving backwards in time was the last one, or the first one, however you want to look at it. And then everything back from there is non-existent. And then they get to be showing up a lot more, and then showing up less until they are non-existent in the year 2764. So there's that one. Then I'm going to move on to this North Fall right here. And the North Fall is cycle Y winter. So there's these that occur in this time, going backwards. The last one going backwards is 1178. Beyond that, non-existent. Moving forward in time, still showing up a little bit after 2038, non-existent. And the third ring in, which is North Winter, and North Winter is cycle Y spring, and that is at 13. Let's spin this around considerably here. here it is. There. The time in which we live now. Going backwards. Before 1080, they did not exist. Shows up more, shows up a lot, shows up less, gone after 2940. Next one up is right here, which is the north. Which one is that? Yeah, that's the North Spring, cycle-wise summer. And we have these. Moving backwards in time. Moving forwards. After 2863, gone. They do not exist past there. So, quite the fantastic time we live in, quite a miracle. We got all kinds of miracles going on here. It's a miracle that these even exist as eclipses here. Because according to the experts here, it's just a coincidence that the sun, the earth, and the moon are all the correct distances for these eclipses to even occur, for one. And then they also have to be the right size for the moon and the sun have to be the right size and the right distance in order for this eclipse to occur. Quite the miracle, because according to the experts, that didn't used to be the case because we were far closer to the sun, and it's not going to occur in the future, quite a ways in the future, but still in the future it will not occur because we will be too far away from the sun, as they claim or say that we are moving away from the sun. Triton 3 is moving closer to the sun for now in the cycle that they're in, and then that will change and they will continue. The Triton 3 will begin to move away from the sun when it reaches there in 3,508.25 years after the Earth date of 2020. So, anyway, I have these others written in here. Begin spring was in the past 11,366.5 years. That's there. And begin winter was here 26,241.25 years ago from 2020. And of course this one, the beginning of the cycle, or 41,116 years ago from 2020. So, just wanted to show you that incredible miracle and coincidence that these also show up on the Triangulactic Shadow Wheel 627. So I think that's about it there. Alright, so we're looking at the Shadow Wheel, Triangulactic Shadow Wheel 1254C. And I want to show you something of how these shadows fall on the wheel over its 18.03 year cycle. So there's 38 of them that land on these 1,254 points of the wheel. 38 of them over the 18.03 years. These here and penciled in here are all the FMC numbers where they land at. It's just an indicator we're looking at over this way. You can see right here the FMC 14F, 14, 16, FMC 16. Okay. So the starting one on, at least on where they're marked on the points that they're going to land at on the wheel, their starting point on here starts at the 2018 eclipse on SW51, which is over here, FMC01F SW51P05. So that eclipse will land on that line right there. There's the 51 center marker. From blue line to blue line is the 1,803 year segment time. So what happens is the 01 and the 02 over here, which you're going to have to look at upside down because otherwise I have to keep spinning this around a bunch of times. So the FMC 02, show you some of this real quick. There's the 02 and the P16. And the next one after the 2018 here is going to go to 2019, January 6th on SW16. So right over here we're looking at, on the even wheel, we're looking at the 16 right here. There's the FMC02, SW16, P16. P16. So probably only show you one of these, and I'm just going to kind of move through them quite a bit faster, and probably not even all of them. So when you line the FMC02 to the FMC01 over here, it's not easy to do with looking through the phone and with one hand. Anyway, they go right across the center point right here. So that makes them a pair. The 1 and 2 are a pair. They're directly across from each other. And then I'm going to move through this a little faster. So then the next one that's going to come up is this one right here, the 03P06. And then it's going to pivot from the 2 over to the 3 over there, which is now obviously not going to be through the center. It's not going to make a pair. But then the 2 or the 3 going over to the 4 here. And there is going to go back through center again. Right here. Okay. So it's just going to continue to do that. So that's going to make another pair. 3 and 4 are going to make a pair. And it's going to go 6, 3 and 4, and it's going to go 5 and 6. And it's 7, 5 and 6, 5 to 6, 6 to 7. 7 to 8, And it's going to continue to do that around this wheel like this. Until it completes all 18 of these FMCs, or if you like, the Saros cycles. And then after it completes that, right there, then 01 will move to the next one over, or the next segment over to the 03, as I'll show you right here. The what am I looking at? It's the 02. There's 01. The 2018 right here is at the 51, SW51, but the next eclipse right here at 2036 is going to be on the SW53. So, I'll show you real quick on that too, because I don't think I've pointed that out yet. So, it's going to eclipse to right here on the same point number, 05. So the next eclipse on the 01, as I was pointing out, that then it goes to from 51 to from the 51 to the 53. So it's going to go from there in 2018, and then in 2036 it's going to land on 53, SW53 P05. Then the next eclipse after that, 18 years later, 18.03 years later, is going to land on SW55 P05. And then the next one on the 57 is going to land at SW57 P05. And it's going to continue to do that until it goes all the way around the entire circle, entire wheel, landing at the point number 05 on each one of these 33 segments. And that will complete that cycle, being 594.99 years. And they all do that from wherever you're starting from. They will go back to they'll land on the same point numbers, but in the next segment up. So anyway, I think that's that for now. There's a lot to tell on that stuff, but that's it for now.